DevOps iterations.
And here we are, third iteration with nobody less than Patrick Debois, who is the godfather of DevOps. Patrick, how are you? What are you doing lately?
What am I doing besides drinking coffee? I guess, I got a new passion around Gen AI and automation. So being now, 15 years of DevOps coming up, I've seen a lot of things like you, right? And it's always about reinventing ourselves and see if we can do better. And now there's a new player in town, and I'm trying to make sense of it and where it can be useful or where it's not useful.
Yeah, wonderful. Actually, you mentioned already 15 years of DevOps, DevOps days at least. No, you had the last event a few weeks ago. Your personal balance on this ride?
Personal balance, I think it's both been very interesting. We are sometimes going in cycles in the industry, but overall, I'm positive. Yes, there's a lot about talking, is DevOps dead or not? But I don't mind too much, right? I think the way that I see it, I explain it as DevOps is a meme, right? And a meme is, officially defined as the smallest cultural piece that you can share or transmit. And I think we transmitted things to the world that there is definitely collaboration happening. There's definitely kind of an improvement on our craftsmanship. Will this have to be like this forever? We don't know. The situation has changed. We're not in a situation where dev and ops are shouting at each other, I think. And it's not about the two big silos. Now we have 100 silos, which is the micro teams working together. So life is changing, and I think patterns apply. So I'm happy with it. My love is it for learning and improving, and I think that's still a very positive result, over all the years.
That's nice to hear. I mean, you are the godfather of DevOps. You are in book history, in history of computing in some ways. So, by the way, how does it feel to be? I mean, you are an historical figure in some way.
It's privilege, right? So it's kind of like watching a show on the first row. You get like VIP tickets, and you watch what happens, and you live with the characters emotionally, and is it working, is it not working, and that's great. I think what's been rewarding for me, if mostly, is, well, I always say you get these emails saying, hey, thank you for starting DevOps, and I founded like a billion company, and I'll buy you a beer. Well, kind of like a beer for a billion company. Anyway, but the most rewarding emails I got over all that period are about, hey, you changed my life. I didn't know there was a better way. Now I have a more pleasant way of working. I can talk to my colleagues. It's a different world. So kind of those personal notes, that's been rewarding in that sense. And besides that, I'm getting old, so it's all good.
And still, you already mentioned that even if you are somehow the father of this movement, you are already moving ahead, so to say. And since we are following what you are doing in the AI world, let's say a provocative question. Have you found what are the examples of Gen AI tools or solutions which were really useful for our, let's say, computing work?
You mean for the work that we do as an engineer?
Yeah.
Yeah. So it's interesting that everybody wants to hear the story, right? Like, what's the biggest impact story? And I always say, well, look at all the small stories that it's improving. I personally, if you go to the whole SDLC, all the different things that we are doing, we're writing some code. The code editors are going through the roof in productivity. Like, I feel productivity that I've never had before using something like Cursor or similar coding editing tools. I get more expressive. It helps me a lot. Then when we move to the testing, there's keeping track of describing what you wanted to test and kind of writing that code, and even visual testing. AI is helping us there a lot to kind of make our lives easier. Doing things in the DOM and end-to-end testing is not fun, but now I have a feeling the cycle is getting so much faster. Then on the prototyping and the ideation, again, we can now turn ideas into code so much more quickly, thanks to AI. And that's insane, because now you can kind of get faster feedback, and you don't have to wait until it's built and kind of work from there. And we're just progressing our CI/CD pipeline. We can find bugs and explain bugs to us easily, in a way that things that were really hard to find maybe get synthesized kind of to us in a better way. And then we go into production, and also there, when we have to deal with incident response, we get a lot more context. The AI is helping us to kind of synthesize the context to find the issues. Now, those are all smaller pieces, but if you add them up, I think the impact has been tremendous on all these pieces. And so I feel that it is certainly changing the way how I work, with the speed that I'm working. Is it perfect? By all means, no. So I always say you still need to know what good looks like. But if you know that, it's definitely going to help you there. Now, then the question often is, well, what if you don't know what good looks like? What do you do then? Like the new people who come into the field and they've never seen this. So of course they can use these tools to get better, but the problem is with especially Gen AI, it can make things up. It can be wrong. We don't know. But I think what I'm now seeing also as a counter movement, not a counter movement, but kind of lifting those people up, is that we're starting to take all the knowledge we have and be able to train new people faster, kind of with the help and more assistive with the Gen AI. They look at a code base, they don't have to ask a senior that explains everything. No, they just use the tools to kind of explore the code base and learn from there. And then they have other things they can learn with some sandboxes and so on. So there's everybody gets lifted up in a way through the whole AI. So is that like the one big use case? No, but again, the sum to me has definitely been changing how it works.
Yeah, I guess you touched all the points about, let's say, usage of AI tools in our daily work, where if you're good at it, at the language you want to write things or whatever technology you are working with, it makes things faster. If you are not good, I tried to do something in a language that I didn't know at all. And the problem is troubleshooting and debugging the small little pieces of errors which are almost there, always there. And if you don't know, it's hard because, but yet still you are learning. So I guess it makes sense in that way.
But you touch on an interesting point in the way that we get better at creating things and it's faster, and our roles is kind of changing from creators to kind of, is this good, is this not good, what's being created. But the preparing for failure and understanding the failure of these tools, I think that's where we can still have a tremendous growth in this field. The analogy that I take is that if you look at the whole kind of DevOps as, the different flavors that have come along. So first, we very much focused on CI, CD, kind of the pipelines and building and automating that kind of building. But it was not we did have to have the tests, right? Otherwise, it was just, go to production faster. No. So we learned that there's a piece that had to have the tests. That's what we're figuring out right now after we got like faster creation of kind of those coding tools. And then after that, we learned that when it runs in production, we needed to have monitoring and observability to explain us and to find why it's not working. So that's I guess. Now the second part is all these AI tools will do something, and you see some hints here and there of tools that allow you to replay what the AI did to understand why it did that. So you get some insights on why and how this was produced. Then we learned that, well, what if we can just make sure that when it fails, it's okay that it fails? That was our resilience engineering. So I think we're going to see similar things like, yes, we're going to have things generated by the AI, but it's okay to fail because we can detect it. We can kind of deal with it. Maybe there's another agent dealing with the failures. So we kind of got into that ultimate thing. And then in the end, we had to learn to train ourselves because we were not used to doing the things ourselves. And I would say that was chaos engineering. Like you fail things on purpose because you want to train yourself. And that's also something, the more and more we're just going to do reviewing and less creating, is that we need to prepare and we need to learn. And that ties it back to my earlier kind of comment on, we still have to learn all the stuff. So if we can accelerate the learning, that's going to be ultimately useful to become a better craftsperson in this.
Do you think we will reach and when the moment where AI will generate perfect code because it will be maybe also ready and trained to test the code itself and see if it works and fix the errors by, I guess, do the full thing in the right way?
Right now, I don't see that point, but what I do see is that it's getting better. So it's never going to be ultimately perfect, what it generates, and it's inherent to the technology of Gen AI. And right now, we're struggling to define what means correct in an automated way. So the tools, the code it's being generated, and that's going to be better. But how do you describe that this code is actually good? So there's a couple of ways that people have been trying to do this. One is they generate code and they run a linter. If the linter is okay and it doesn't complain, then the code's good. Well, that's it's kind of like, does it compile? That's what we used to have, right? So the next one is you write some tests for this, and then see if the test becomes valid. But there's still, well, if the AI is also writing the tests and the generation, well, there's a tricky part, right? Well, you can use another model to, test the other model, but it's still a little bit tricky. Looking at syntax, yes, we can do some static analysis and see whether that's okay, but it's still kind of unclear. So that verification step is not yet cracked, in my opinion. It is maybe for other parts like text generation. We know, hey, there's a pattern called RAG, and we kind of add some more knowledge to it, and it improves, and we can show you kind of the test set. For code, that's still a little bit out there. But yeah, it's fascinating to see it grow. But the tricky part is, let's say it becomes, now it's obvious that it's not always good. But when it becomes 99.9% okay, Then we'll have to rethink like, how do we cope with the other? Are we still going to review everything, or are we going to re-architect in a way that it's okay to fail, and we'll find the failure and we kind of deal with that? So that's kind of where the struggle or the search is for. But don't believe it's going to be perfect anytime soon there.
I guess interesting times ahead. And on this matter, how do you think where we will be here in the IT, let's say in the operations and the infrastructure world in 10 years? How do you foresee the computing world?
I keep wondering whether it makes sense to have, not make sense, but let's say it like this. I see a lot more people working from specifications to code generations, to definitions. So the code that we're still reviewing and typing ourselves right now, it's almost like it's a model for us to understand what the machine is doing. It's less about us telling the machine what to do, but it's more to understand what it's doing. So if I can specify more, like, let's say I want 2 AWS machines, I want them to look like this, and they always have to be in that region. What I can see is that there's a part that will be just text specification that will kind of translate into intermediate code. And then there's maybe some pieces of code that make sense to express it like code. So kind of a mixture between both, but some things are quite hard to express in code and some things are hard to express in a specification. But I maybe there's like a merging of kind of those two pieces, almost like your guidelines are like this, but your code is, here's some pieces. And then it gets transpiled to an intermediate code. So that code becomes less and less relevant unless it is for debugging and understanding for us what it's still doing in a certain way. Anyway, I don't know. I don't have a crystal ball, but this is kind of a narrative that's been coming up on me.
Yeah, I mean, this reminds me the idea that while technology in the last years, in let's say 20 years or so, which I guess we have lived in terms of IT and landscapes, there has been a complexity raising, no? More and more things to manage, more and more abstraction layers. So more complex systems. At the same time, they attempt to make easier the things for the end users. And this sort of, let's say, conflict between user-facing tools or solutions, which are as much simple as possible, complexity behind and below, under the cover, so to say. And and so at the same time, you need more skills to be able to understand the full stack, and less skills because you don't need to understand it well until it works. So how do we, the IT person who works in the IT at different levels, from operations to development to whatever, how do you think we should tackle these conflicting trends in some way?
What you're describing is called the ironies of automation. There's a paper about this. So the more you kind of automate, the simpler you make the simple things, the harder you make the harder things. So you as an end user, you get the abstraction layer, and then the person implementing the abstraction layer has a really hard time to deal with all the abstraction differences, right? So how do you deal with this is with that complexity, you kind of first of all, the software needs to adapt to the mental model of the person doing it. So for some, that mental model is YAML file, for some it's coding, for some it's like another thing. So this is kind of why I think there's so many different flavors, because everybody kind of has a different model that kind of they operate in. Then you want to have, obviously, when you are doing a certain task, you don't want to have the boilerplate. You don't want to have you want to do it by small tasks. So you don't want to write like, hey, do all the things. No, so you kind of want to have almost like mental, reduce the cognitive load by saying, hey, this is the piece that I understand. Remember those kind of big files of Puppet in the past? No, we kind of split them up in smaller pieces so we can understand what each of the classes is doing and kind of work from there. When you're working on this, when we come back to that debugging, when it fails, you need to have a good way of seeing where the failure is happening, and the interface needs to adapt itself to that as well. So these are all described in a paper called The Ironies of Automation, which was kind of instrumental early DevOps era. And then this is now being completely reused in the automation with Gen AI, because you can see, for example, in your code editor, when you have a Copilot, there's multiple ways of seeing a diff when something changed. One is, okay, I just see the typical red-green diff, right? That's okay. The other one is more like a summary. This has changed, and this what you're doing, or almost like a PR with a whole description. Hey, this is what I've done. Almost like a chat discussion. Hey, I did this, and then I did that. And then you can have now a third one, which is, I'm going to watch inline in my code, and it's going to show me this, but it's going to abstract away the things that are currently not relevant to my diff, and it's just going to say existing code. But it tries to focus us on where we need to be for solving this problem. So this adaptability on dealing with the harder problems is just one example of how we're going to reduce the cognitive load. What we're seeing, for example, on the code generation is that the AIs first were generating bigger files and harder to understand. So all the time we saved in the creation now went into the review. But again, by reducing the cognitive load and doing this more clever, we kind of reduce this. And I think that's the same thing with an infrastructure. There's a certain zoom in, zoom out that you want to be flexible to understand, hey, I'm working on this kind of very specific piece. Now kind of remove all the stuff around us, but still inform me of the stuff around it. And then kind of, oh, now I'm going to go to the macro level, and then I'm going to code. So kind of switching those layers of models, I think is a useful thing to deal with it.
Interesting. How will be your computer when you will be 100 years old?
Oh, I'll probably just talk and talk to an avatar or something.
No more keyboards, no more QWERTY under the fingers.
I'm a bad typer anyway, so I don't mind too much. Interestingly enough, I just in a couple of weeks I made a prototype, because most of the time now in the coding tools I'm writing specification. I tell it what I want, but I'm hardly writing what the code is anymore. So if the code is not correct, I just give it a follow-up remark, and then I see it adapts the code the way I want it. So I changed it in a way that I had a voice interface, and I can just, I raise one finger and it just types what I want. It raises two fingers, it executes what I say. So I can see myself using this in a certain way. And I can also see the AI better understanding what I do on a day-to-day basis, and keeping track of what I was working on, and just talk it through. Oh, this looks good. This doesn't. Oh, so it's almost that reviewer function with a personal assistant or a rubber duck that kind of helps it that way. So I know it sounds maybe weird that we'll be talking more again, but then again, it's the same thing that you want to switch between models. Some things are hard to express, and others are quite easy to express to a person who knows kind of the context that you're in.
Right. I guess an
So,
open space working place would be a madness, like a call center. Everybody talking, do this.
oh, well, you know, we all have kind of directive microphones implanted in our nose or something. I don't know.
We will see. We will see.
Yeah.
I always ask if some names of people that you know that you would suggest to host in this podcast.
Well, I know a lot of people from the more agile community, closer to the DevOps. So Michael Nygaard, I don't know if that name rings a bell. He has once written a book called Release It. And he's now been doing quite some work around using DevOps practices for data. So that's definitely a person I would recommend in this. And he has kind of the both backgrounds, system and kind of more of the agile world. So that's definitely a person I would recommend.
Interesting. Computing, computers, servers, so to or server side stuff, or whatever
Yeah.
is in data centers and so on. I mean, we have seen trends going and coming back. Again, your prevision, your forecast for the future, let's say in 5, 10, 20 years, 30 years, how will be the server side, so to say, computing landscape? Where we will be, our computers, our servers, in hyperscalers, back to our data centers, everywhere, and how they will look like in some way.
I don't think I have a very good informed opinion on this. It's ironic to see people coming back to their own data centers, definitely. There's also definitely an era of, well, my phone is already very powerful for certain things. There's definitely a trend towards more privacy related things. So I don't know how that's going to pan out. Will that still be a little bit more local to a user because we don't trust the bigger compute anymore? That's unclear. I think there's quantum computing and all that stuff, but again, I'm not the best person to talk about this stuff. What I find fascinating is the idea that whatever goes on your computer right now, in a way that it's getting tracked all the time. So it's almost like you would have a personal space somewhere on a server. And I know that's not too different as having a social media thing, but it's kind of those kind of safe compute spaces for where nobody can get to or something. But yeah,
Well,
again,
we may discuss about nobody can get there because it's all.
well, yeah, it's like probably not feasible or something with unless with certain cryptos and so on. But it there's definitely the discussion about will it stay that centralized, in my opinion. Is it in a way that we're more storing about our personal things and kind of where that's going to belong? And will that be together with our compute closer, or will we just expose that data to compute everywhere? Again, I'm not sure how that's going to work. I have the tendency to still put things in my basement, but it's probably not the best way.
Your local data center, home data center.
No, I don't do that anymore. But there's a certain truth in there. But again, I'm not. I haven't thought this through as a story, to be honest.
So you
Maybe you have some ideas.
I don't. I guess there will be the usual madness, no? The everything of everything. So all the kind of different things, because as is it now, I don't think is going to be different in the future in terms of diversity of solutions, approaches, kind of things around, no? From mainframes to physical servers to cloud to local cloud to according to sizes, kind of companies, kind of business they run, and all this kind of stuff. So under some points, I don't know what will be there, but it will be a chaos in some way as it is now.
Yeah.
How many of that differentiated, many different things around.
Yeah.
In some way.
I've seen one interesting model, but it's, I guess, not very refined, but it's what if we put the LLM more at the core, like a CPU of a machine? So that whatever it's doing is kind of, it gets a memory, it tracks through sensors, multimodal what it's doing. So you'll kind of find this LLM OS or something. There's some papers around this. But it's interesting that it's like non-deterministic technology that you put into control of a machine.
Exactly. What happens when?
But yeah, anyway, it's fascinating. And then I think Microsoft did something similar to. So one of the things they do is they have a solution that tracks everything on your screen all the time. So you can ask it like, what happened? Like, where was that presentation that I shown to this person, and so on. And the answer to their kind of privacy was, well, we can provide you with a local kind of server with an LLM that's on that machine, and your data never leaves that machine. So maybe that's kind of like where there's something heading. Who knows?
And the funny thing is that what seems huge, a local LLM running on our system and doing all the stuff which now is can be done only on data centers, is going to become normal, I guess, in some days, some week, in some years, with the technology advances and the computing power we will have more and more at disposal.
Mm-hmm.
More computing power, more energy.
There's that. Yeah.
There is that. And will they become conscious?
Don't think so. It might feel like conscious, but it's not conscious.
They look like but let's say consciousness is, I guess, is maybe vague definition, but they will be able to do things, so to say, unexpected. They're already doing that, no? They were not supposed to be doing to do. So I don't know how to explain, but we rely on LLM for the moments for simple instead of better contained tasks, so to say. No, write this summary, generate this picture, do this code, and so on. And I guess we will empower more and more these models to do things more or less automatically and autonomously, hoping that they do the right thing always, or they behave, maybe placing some gates, some restrictions. But then the question is, let's say there are gates, they will be able to autonomously circumvent them. I don't know if it's consciousness, but maybe it's just,
I think there was a
logic.
story a couple of months ago where they were having an autonomous agent that was having to solve issues on the infrastructure or something, and they were letting it, kind of unlimited or unconstrained in a way, like just, of course, in a sandbox environment. But they found that the LLM eventually found a way to kind of get out of the Kubernetes cluster by doing some shell code and stuff. And so then it could watch a layer behind the scenes. So it was that unexpected. Of course, they were not expecting it to do this. Is it to be expected that, randomly it would do that? Of course, but the fact that it succeeded is probably, in a way, should not surprise us in a world kind of full of bugs like that.
So the point is what we do then, and if we leave some, because I guess the trend is, riding the wave,
Yeah.
and we will permit AI to do more and more things.
Well, it's a trick question in a way that, well, what stops me from going to your home and taking everything from your home, right? So there's a certain police, okay, fines, there's some laws. Some people will never kind of adhere to those, and they just do whatever they want. And for others, that is enough to restrict us. It's almost like there's in teams and events, you have a code of conduct. Like it's kind of having code of conduct for your agents that say, well, you're not supposed to do this. Don't do this. One thing is restricting them. The other one is kind of telling them this is not good behavior. Will this be enough? No. But it reminds me of PayPal, or no, Visa. I mean, Visa is not really a safe system if you have to show the numbers and tell the numbers and type the numbers, but somehow it kind of works. But because we have mechanism to cope with it when there's a failure, fraud, and there's a system in place. So I don't know. The impact is probably going to be way bigger if we're going to do unconstrained things on the internet. But I don't see a lot of other mechanisms to kind of do this. We can agree, but it doesn't mean everybody will agree. So that's kind of like tricky. I think it was Mark Zuckerberg who explained his mission for open models in a way that he said, if everybody has access, the good and the bad guys have the same tools. If the bad guys have way better tools than the good guys, then we're in deep trouble. So that's why he said he wanted to commoditize kind of
Well,
this.
I have my own personal opinion why he open sourced the AI models. I guess because they were behind. And so what can we do in this landscape where there is already OpenAI way ahead? Let's
Sure,
open
you
source.
needed a different angle, but I'm just saying this was the narrative.
The official, the narrative.
To the table. And there's some truth to that, kind of if everybody's kind of fighting with the same weapons in a way that, okay, that feels still a little bit fair. But anyway, it's I have no solution.
And
Come back in 100 years.
And talking about weapons, I mean, the point is it's powerful. These models are getting more and more powerful, and we know that we can take for granted that there are, let's say, evil people around, people who don't follow laws or who don't care about ethics or whatever. So we will have to cope with that. No, I mean, we can also have let's say, the AI which is inherently good or is not going to become darknet, but at the same time we will have malicious actors which will have these weapons at disposal. And how can we face these new challenges?
There's a funny story about I think it was Evil GPT or something, and they asked it like the question about like, can you wipe out humanity or something? I don't know, kind of like this question. So, and they saw it kind of go on the internet, look on Wikipedia, weapons of mass destruction, and they kind of like go all the stuff. And one of the main reasons why it didn't go through and it kind of kept going idle is because it could not find the API for nuclear missiles.
Not yet.
Not yet, indeed. So that brings it back to the resilience, right? So it's kind of like you contain certain things, and you kind of design more and more things. But like we learn in our day-to-day life, it's That's not like our usual reasoning that gets applied there. But yeah, anyway, I think as much as I kind of value that discussion about how to deal with this, it's obviously the technology for good and for bad. There's both uses. Banning the technology because of the bad things and not on the good things. I'm still kind of I think it should stay open for use, and I think that's the best protection right now. But time will tell, right?
Time will tell. By the way, what is your opinion on the AI Act from the European Commission?
I think it's I like that they put a stance in there, in a way that, these are the levels, this is where it's allowed, this is where not allowed. So it is kind of forming a part of that legislations in a certain sense on, hey, this is what is legal considered, this is what is not legal. Those kind of debates on, hey, certain technologies are not available in the European Union. It's a tricky thing, and that's the economic side of this, of course, right? If you're banning too much of the technologies, then the difference between, and we've talked about this before, if the difference between the two powers becomes vastly different, then we have a different problem. So yeah, again, it's not something we're going to solve on this podcast, but I like the stance. I like that they demand the attention of thinking about this, that there's a certain push on this, that it's not for granted. You should not go into the Wild West about applying this. But then I also look at the implementation of cookies and GDPR. I can't say I'm the most happy person about this. But there's it is to be refined, and I think in the US as well that there's definitely attention to this more and more, but it's a mentality problem, and the laws will not stop people, so you kind of have to understand, like, what are you protecting at what cost. So
Yeah, I guess it's the usual conundrum between regulate something and don't let the regulation block things or annoy people too much. And the cookie, when you mentioned the cookie thing, actually, it's emblematic of this. Oh, by the way, what is your favorite LLM model?
whew, I think I don't believe in the one model, but I currently probably use the O1 OpenAI model, in the fact that it's doing part of the reasoning. So the others are more like the text generation, but this one with the reasoning built in, I think that's helpful, and I think that drives other models. If I do something in code, I use kind of a specific code generation model. If I use the text, or if I use a JSON, so it depends a little bit on the tool, but I don't believe in the one model that kind of will be perfect for all use cases, in that way. But one model that orchestrates another that's really good at its task, and so in that way, I again, I don't see the one model shine per se.
Mm. And I mean, in the last 2 years, after the ChatGPT explosion, we are all talking about LLM models, LLMs. But I mean, that's not the only paradigm, no? Not the only
Sure.
way to do. Do you know enough, or do you see some alternatives to this approach of AI?
Well, we had the traditional AI more of the prediction by training. So that still applies. But I think the interesting with the LLMs is that there's a certain emerging behavior that you train it on a vast things of things, and all of a sudden it can do a new thing. And as an alternative, I haven't seen anything specific or so that comes close. But if obviously if it will generate things that you can control better, then it's interesting. I do quite some stuff also with imaging, and for a lot of people, when you do text to image, it's never exactly how you want this, right? So it's like, oh well, I wanted this tree a little bit more on the left, and so on. So I think what you see as the almost like a constant is you use the generation for power, but then you add a little bit of structure. In the past, we had to put a lot of structure, but kind of the generation with a little bit of structure, that gives magic. So if I wanted to an image of a tree, I just draw a tree in this place, and then I say, use this image, use this text, and generate this. So that's kind of how I see these things evolve, is that we're going to get better at defining the tools around the LLM to have it explain a little bit more on the structure we want, and kind of then unleash the more power. So that's not really an alternative kind of technology, but I think it is useful in that way. Whether you're generating an avatar in a 3D engine, and then you apply a deepfake on top of this, right? So it's like a structured thing and an unstructured thing. And it was the same example, like you do some specifications and here's some code. So kind of that balance between structured and unstructured. And a lot of people now think like, oh, the LLM is going to figure it out on its own. And the old way was like, we're going to just give it so much structure, it's going to be perfect. So that balance is, I think, where the sweet spot of emerging new things will be.
And in this world of images, actually, if you think about that, now all our perception of reality outside our, let's say, physical direct perception is based on something that we see on a screen. And now we can manage to show whatever on a screen. No, everything can be generated. Is this possibly becoming a problem in the short or long term future?
You mean that we're
for
able
example,
to
fakes of videos? No, if it happened to show a picture or something like that, now you show a picture can be fake and could be totally realistic, and it's hard to distinguish if it's real or not. And
indeed, it's again one of those technologies that is disrupting. How do you even know I'm talking to you and not my bot, right? So, and then use that for bad purposes. And that's the sad part, is that we probably often get the creation part first, and then we get the governance and the control part second. Companies are working around this on this kind of let's say it's more like watermarking or making sure, or a registry of this is allowed or not, but it's still a long way to go, and until then it's unfortunately still a little bit of the far west on what is possible, what is allowed, because legislation tends to kind of and the solutions tend to kind of be later in that phase.
Yeah, and also I guess laws are not enough to prevent things from happening.
Indeed,
So Patrick, one last question is the question I haven't asked. Is there anything that you would like to reply to which I haven't asked?
I think when you asked me about the compute, I was kind of a little bit like, I don't know. And it made me maybe realize like it's almost like a solved abstraction layer for me. But it doesn't mean it cannot evolve, but it's like it shows how much abstracted I'm getting away from kind of the compute and the machines, thinking about it less.
So no more hands on the hardware, no more connecting
Who
cables.
knows?
The good old times are lost.
Yeah. Then you cut your finger because of your PCI card or something, right? So
Right, you can just talk and things happen out of the box. Wonderful. Thank you very much, Patrick. It has been very interesting for me to listen to your words, and I guess it will be the same for whoever will see this podcast. See you, I guess, soon in Belgium.
yes, absolutely. And thanks for having me. Good luck with the show.
Thank you. Bye-bye.
Bye.
Abnormal DevOps iterations.